This is the lesson for Chapter 6, Section 1, Day 3 on solving systems by graphing. Let's take a look at our first problem here. And it's talking about two professional downhill skiers are racing at speeds shown in the diagram. So here are their different speeds. And skier 1 starts 5 seconds. Starts 5 seconds before skier 2. That's going to be some important information. It says the course is 5,000 feet long. And so it says, will skier 2 pass skier 1? And we're going to answer that question of how we end up knowing. So let's start with a formula here. We're going to use this formula. Distance equals rate times by time. And so distance is our dependent variable. It depends on how long we're traveling at a certain rate. So let's go ahead and fill in parts of our graph here. Our axes we'll label with distance along the y-axis. I like to have the dependent variable along that y-axis, and it's in feet, so I'll put those units there. And then we've got time running along the x-axis, and that time is in seconds. Now I'm not sure what kind of intervals I need, but I do know that I need to make it up to 5,000 feet. I want to find out how long the course is. So I'm going to be looking at my intervals here, and I notice that there are 10 spaces going up. So if we go by units of 500, we'd be able to fit these values in here. So I'm going to put 1,000 along this line right here. So this is 500, 1,000. And then every other line I'll write in there, 2,000, 3,000, 4,000, and 5,000. And then along the x-axis, not sure what kind of times we're going to need until we figure out how long it's going to take them. So let's start by writing our equations here. So we got two different skiers. We got skier 1 and we got skier number 2. And so on this first one, I'm going to set up it this way. We got distance equals the rate. Well, skier number 1 travels right here at 100 feet per second. So that's the rate. Now the time is t plus 5. The reason why it's plus 5 is because right in the beginning we read it and it says they left 5 seconds before skier number 2. So I'll go ahead and distribute, and I've got distance equals 100t plus 500. And from that point, I can go ahead and find out how long it's going to take them, because I know the distance, 5,000 feet, equals 100t plus 500. So I'll go ahead and subtract that 500 from both sides, and that leaves me with 4,500 equals 100t. So when I divide by 100, it looks like it's going to take the person 45 seconds to get down the hill. So that's the time I need for skier 1. Let's check out skier 2. Distance equals rate times time. So the rate is 110 feet per second times by t. So again, I know what that distance is. It's 5,000 feet. And when we divide by 110, oops, not 100 this time, but 110, I can cross off these two zeros and see if 11 goes in there. And it ends up being 45.45, and that 45 repeats, and so that's how long it's going to take them. So I see that it's going to take skier 2 longer to get down the hill. So I already know that, but I'm going to show that in this graph. So I know it takes 45 seconds, so let's see what kind of units I should go with. So if I go by 5s, I'll get right to 45 seconds. So let's go ahead and call this one 10, 20, this is 30, 40, and this will be 50. And so 45 will be right along this line right here. So I know that for skier number 1, I can graph some points. He starts up at 500 feet, and he ends at 45 seconds at 5,000 feet. So his line is right in between here. And we can even use his slope because it's easy. It's 100 feet, or 100, yes, feet per second. So if we go 1,000 feet, it's going to end up taking him 10 seconds there, so we can always just end up going up like this. And so 1,000 feet would end up being right here, because we start at 500 feet, and we can continue that going up. And you'll see we'll end up right at that point. So you can see how it'll end up going right through there. So it's kind of going up nice diagonal angle right through these coordinates here. Where the other skier, and he ends up right at 45 seconds, starts at the origin because he didn't get that head start, and he ends up at 45.45, so still close. We can't even really draw it very well, but you can see how he's going to end up getting closer and closer and closer and closer, but just never quite touches. And then after that 5,000 feet, then the skier that's going a little bit quicker will end up passing. So we would say that in this case, skier 1, well, will skier 2 pass? No. No, skier 2 will pass skier 1 after the 5,000 feet. And so somewhere after that, they will end up crossing. And the reason is that because skier 1 takes 45 seconds to go 5,000 feet. And skier 2 takes just over 45 seconds, 45.45 seconds repeating. And so that's how we end up knowing, and we showed it through the graph. Let's take a look at another type of problem that we might end up seeing. It says, scientists study the weight of 2 alligators over a period of 12 months. The initial weight and growth rate of the alligators are shown below, so they're right in here. And then it says that after how many months did the alligators weigh the same amount? And so let's go ahead and try to write an equation for them and identify what the variables represent as well. So I'm going to say that y equals pounds. So just like we had before, we wrote an equation on the last problem, I need to start defining some variables. And so they don't give me any, so I'm going to use y and x. So y is pounds, x is months. And typically time is going to end up being our independent variable, and it is in this case. And if you think about it, the pounds are not going to influence the months. The months are going to influence the pounds. As months continue, pounds are going to increase. So we're going to put months down below, time in months. That's going to be our x-axis. Our y-axis is going to be weight of the alligator in pounds. And so we don't know what kind of units to use yet until we start looking at the equations. So let's take a look at alligator 1. So I'll just call it Al1. And when I look at its equation, it's going to be y equals, so its output, its weight is, now its initial weight is 4 pounds. So we've got 4 pounds, and then we're adding on its rate at which it grows. So rate tells us our slope. So it's going to be 1.5 pounds. So 1.5 times the number of months, because 1.5 pounds per month is how it's growing. That's its equation. Alligator 2, and so I'll call it Al2 there. And we have an initial weight of 6 pounds, so a little heavier, and it grows at a rate of 1 pound per month. So eventually, alligator 1 is going to be more heavy because it's growing at a faster rate. Alligator 2 starts off a little heavier though. So since it looks like I've got some pretty decent numbers here where it's I don't have to start up too high like I did in the last one, maybe I'll start with going by 2's. So I'll put in 4 here, and this would be 8, and this would be 12, 16, and 20 at the top. And by time, why don't we just go by 1's? So this is 1, 2, 4, 6, 8, 10. And so these are months in here. And we don't have 12 months, so we're going to end up having to do some work to be able to find out what it says scientists study the alligators over a period of 12 months. Okay, so we're just trying to find out when, after how many months did they end up being the same weight. So let's find that out. So let's go ahead and start by graphing this equation. Now when I graph this, I'm going to use, instead of 1.5, I'm going to change that to 3 halves. 3 halves is the fraction form. It's a little easier to graph. So I'm going to start up 4 spaces right there, and I'm going to go up 3 spaces. So this is 2, and 3 is going to be right in the middle, and then over 2. So 1, 2. And then I'll continue doing that. So up a half for that 1 space, and then 2 more. That gives me up 3 total, and then over 2. And I'll just continue. And so up 3 over 2, and then up 3 over 2, and then up 3 over 2. So that's the first one, and let's take a look at the next one. So it starts at 6 pounds. And we'll go ahead and start it right there. And it's increasing at 1. So when I write its variable, I'm going to go up 1 over, up 1 space because that represents 2, and then over 2. And that way I show going up 2 pounds for 2 months, so 2 pounds every 2 months, so you can see how it's going to end up crossing right at that point right there. And its slope ends up looking like this. So you can see how they cross right there at 4 months. So it looks like the answer is right here. If I go straight across, this is the number of pounds, and this is the number of months. So what the graph is telling us is after 4 months, each alligator will weigh, and then we've even got the weight right here, 10 pounds. So at 4 months, maybe I'll even change that right now. So because after, we're going to end up seeing alligator number 1 will be a little bit heavier. So we'll say at 4 months, each alligator will weigh 10 pounds exactly. And then afterwards, we're going to end up seeing alligator 1 being a little heavier. So let's take a look at the next problem here, and it talks about cell phone plans. The cell phone plan provider offers a plan that costs $40 a month plus 20 cents per text message sent or received. In comparable plan, it only costs $60 a month with unlimited texting. Okay, so let's go ahead and write out our variables. We've got y is going to end up being our cost in dollars. X is going to end up being, what changes right here is it's $60 per month, but what changes is the texting. And so we're going to say the number of texts. So that's what's really going to change plan number 1's cost right here. So even though they said per month right here, $40 per month for the cost, we're just going to look at how many texts we'd have to have in order for the time over 1 month to be the same or greater. So we're going to end up putting cost along the y-axis, and that's going to depend on the number of texts. So I'm going to even put number of texts. And so now we need to write an equation. So we've got y equals, let's put on our first plan, so this is plan 1. Plan 1, so it's going to be y equals $40, the initial amount, plus the 20 cents per text. Where plan number 2 is just $60, no matter what. So that's just y equals 60, no rate to change. And so when we go ahead and look at these numbers, I got to start up 60 on one and 40 on the other. So let's go by tens. Let's call this one 20, 40, 60, 80, 100. And so each row is 10, or each mark is 10. And how about for number of texts? Let's find out what I need here. So let's go ahead and we're going to start by, if I end up looking just at this 2/10, 2/10 is the same thing as saying 1/5. 1/5 x plus 40. And so just by looking at that, if I wanted to find out how much until they're the same, I'm going to go ahead and put 60 right here, because that would end up being the same amount. And if I subtracted, I would end up getting 20 equals 1/5 x. So look, if I go ahead and solve this, I'm going to have to multiply by 5, and that makes 100. So I need to be able to show 100 minutes on this. So I'm going to end up going by tens here as well. So this is going to be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So they're going to end up crossing right at that last point. And so we'll start off with the first one. Plan number 2 actually is $60 no matter what. So every single time it's just going to be right along this line right here. And then I'll just go ahead and draw it in there, so it's going to be right along that line that they'll end up crossing, because no matter what, the plan number 2 is $60. Now let's find out plan number 1. We start off at $40, and then it increases. And so as we go up, you can see that if we go up by, let's say 10, let's try 20. If I just go up by 20, 20 times by a fifth makes 4, so that makes 45, so that's going to end up working. So if we put 20 in here, that'd be 44. That's kind of hard to do, so let's go ahead and go up maybe by 50. So let's try that. Y equals, and then we'll do the 1/5 times by 50. If I go 50 minutes, that would make this 10, and then 10 plus the 40 would give me 50. So at $50, it's going to be up at this amount. At $50, it's going to be 50 techs, and then at 100 techs, it's going to finally be at 60. And so that's where they're going to end up crossing. So it's going to take 100 techs in order for them to be the same. And that's what they're asking here, is how many techs would you have to send in order to have the cost the same each month, and that would be 100 techs. So part A, after at 100 techs, the cost would be the same. And then question B says, if you send or receive an average of 50 techs each month, which plan would you choose? Well, I would end up choosing plan 1, because at 50 techs, the cost is $10 less than plan 2's. At 50 techs, we saw that it was only $50, where plan number 2 is $60. So those are the types of problems you're going to end up seeing on tonight's homework. Goodbye.